Hello. Oh, day 11. We've got 2 days left, kids. 2 days left. Something's on my eyeglasses. Oh, much not improved. Okay, we're going to do a little bit of linear regression today. Linear regression analysis. Now, this is, again, something not new to you kiddies. You did this in Algebra 1, Common Core. Common Core. Now we're going to do number 2. Let's just take a look at some things. We're going to go to this website, and it says change n to 10. So that's the first thing we're going to try. So we're going to go to this website. I thought I had it up. There it is. We're going to go to this website. We're going to change n to 10. I don't even like the fact I can't see this. There's a way to zoom in. My mouse is not working. Nope, whatever. So let's change n to 10. Let's see what happens to these points. There's got to be a way to zoom in. Oh, well. So less points. Now notice that my R value right here is, I hate the fact that I cannot zoom in. I'll bet there's in settings I can zoom in. Zoom in, yay. Hey, I found it. Gotta love Chrome. All right, so there's our things. Now we've reduced it to only 10 items. I don't want you to see that many items. I want us to get a look at it. Now the yellow ones, so let's take a look at these items. So as I look here at R is my regression correlation coefficient. R is my correlation coefficient. What that tells me is how correlated these dots are. So what we should notice as we scroll, let's take R down to like almost 0. What do you notice at almost 0? They're all over the place. I got dots down here. I got dots up here, here, all over the place. Now, as we get closer and closer and closer, now we're just running constant simulations. There's 50%. Nah, they're still kind of scattered. Watch what happens. Now we're going to 0.6, 0.8. Notice what's happening. Notice what's happening. And then when we get almost all the way to 1, they're almost all on the line. Take it down to 0.95. A little bit off the line, all on the line. A little bit off the line. When I get to 0.8, they're close to the line, but all off the line. Now what happens when I go this way? Now when I go down, they get all spread out. You know, maybe we need more than that. Let's get 20. I like 20. Get more points. They're all spread out. So we go over here. Let's just watch them. Go. 0.84, 0.985, 0.95, 1.0. They're all in the line. Now when we go down to 0, they're all over the place. Now what happens? Watch. We keep going left. Our correlation coefficient is negative, and lo and behold, the slope of the line of best fit is, in fact, negative. Now watch what happens as we get closer and closer to negative 1. 0.79, 0.81, 0.86, 0.91, 0.96, negative 1. So that should come as no surprise to you. Okay. By the way, that was not the actual regression line. That's the averages line. This is the regression line. And let me show you that because it's actually a better line. You'll see it's the regression line. It's the line of best fit. Line of best fit. You know. And when you're down at here at 0, look how far away the points are from the line of best fit. It's like you could put that line anywhere. I mean, I guess that's the line of best fit, but who's to say? At any rate, that's that. Let's talk. Let's keep going. Oh, we forgot. We forgot to bring Mr. Notes out. Mr. Note. Or no, I'm sorry, Mr. Key. Mr. Key. Mr. Key never makes any mistakes. He's the bomb. All right, it's just me. So what happens as R gets closer to positive ones? The points get close and closer to the line. And the slope looks like it's a positive 1. Well, we don't really know about the slope, but the lines, they get closer and closer to the line is what I want. And we got a positive slope, positive slope. What happens to the regression line as r gets closer and closer to 1? I think it gets more accurate. It gets more accurate. Includes more points. What happens to r as you get closer to 0? What happens to the points as r gets closer? Spread out all over the place. Regression line as r gets, let's take back a look and see what happens. What you're going to see is the regression line when you're close to 0 is just like all over the place. Let me just get you the regression line. The regression line is just a green line. So watch, look at it. When you're close to 0, look at the regression line. It's like got a slope of like 0, doesn't it? Because it doesn't have a clue where to put all these points. So anywhere I'm near 0, that slope's going to be near 0. And as I get closer to 1, what's my slope going to be approximately? Over 2, up 2, over 2, up 2, over. So we went out 10 and we went up 10. Slope of 1. So as my regression line gets closer to 1, my slope goes to about 1. As it gets closer to 0, my slope gets to be about 0. It becomes a horizontal line. And as my slope gets closer and closer to -1, the points get closer and closer. The points get closer to line, and they're going down. And what happens to my regression line? The slope gets closer. Let's just say the slope gets closer to -1. So here's what I want you to get out of this. If r is close to +1, high positive correlation. As r gets closer and closer to -1, it's a high negative correlation. And if it's near 0, it's less than, let's say it's less than like a half. It's like no correlation at all. It's like all over the place. It's random. And what we mean by correlation is one thing affects another. As I get taller, I probably get heavier. As I get older, I get balder. Sometimes yes, sometimes no. It doesn't always happen. Correlation coefficient. It's going to go from +1 to -1. And in 0 in the middle. High, positive, high, negative. And in this area, pretty much no correlation. So if r is, points lie on the line with a negative slope. So that would be points lie on the line, r equals around -1. And they lie on the line going in a negative slope. If do not lie on the line, or do not lie near the line at all, that would be like a r value of 0. That means you got points just all over the place, and there's no way anybody could draw a line of best fit. And then r of 1, you're going to have a positive correlation, and the points are going to be really close to being a nice straight line. So we're going to estimate the correlation coefficient. So I'm going to say on this one, since it's not all on the line, I'm going to say 0.98. This one, if you just get rid of this point maybe, and this point here, Generally, they're going in a positive direction, but they're kind of all over the place. So I'm going to guess point R equals like 0.6 or maybe 0.7. Now, these are really close to a straight line, really close, and it's negative. So how about an R value of like negative 0.99? Something like that. Wow, very close to being a straight line. I mean, that almost could be 1. R equals 0.99. I don't know. Maybe this one was 0.97. This one, generally, they're coming down in a downward direction. So I would say something like negative 0.6. And if you'd said negative 0.5, I would be okay with that, or negative 0.7. I'd be okay with that too, because they're generally coming down in a downward direction. Mostly I want you to know whether or not it's negative or positive. So we're going to do a little bit of work. We're going to use our calculator to do this. So the temperature, the table below shows the temperature in Fahrenheit of the different water depths of Lake Ontario in August. So if you're 41 meters deep, kind of cold. And the closer you are to the surface, it gets much warmer. So we're going to need our calculator for this. Let's see if I can kind of get this on half my screen. Here we go. So here's how it works. That's from the last thing. We'll go into our spreadsheet. And this is my depth. And this over here is my temperature, because the D is the independent variable and temperature is the dependent. So it depends on how deep I am, it depends on what the temperature is. So 47, 30, 12, and 5. And you'll notice the temperature is going up. 41, 58, 58, 59, and 65. Now, before I do any math on that, I want to see if I can start to predict some things. So what I want to do is graph these points. So 47, 41. So 47 would be here. And, oh wait. D of T, depth at a particular temperature. Well, I want to apologize. I think I put this table in here backwards. So apparently we're going to put the D on the y-axis and we're going to put the temperature on the f-axis, because it looks down here, I've got temperature down here. I hate this. We're changing this. So this is, well, let's just put the temperature here and the depth here, because some of that didn't make sense. So 47, 41. So 47, 41. Right about there. And then 30 degrees and 58. So 30 and 58. And 12 and 59. And 5 and 65. Now, if I had to draw the line of best fit in there, and I drew the line of best fit, it would look something like this. Now, are these points very far away from the line? No. But you'll see that it has a negative correlation. But it's pretty close. It's pretty close. So I'm going to guess, we're going to estimate a correlation coefficient of somewhere around negative 0.96. I'm going to guess negative 0.96. Those are pretty close. Those points are pretty close. There seems to be a direct correlation of temperature with the depth of the water. So let's see if we can do this. So we're going to go to our calculator. We've already got this stuff typed in. We're going to put your blue cell right here, and we're going to go into Menu, Statistics, Stat Calculations, and we're going to do linear regression. And the only one we really know is mx plus b, so that's what we're going to do. And you got to tell it which list. So you're going to tell it that the depth is our x list and the temperature is our y list. And we're going to click OK. So here we go. Here's what we need to know. We need to know our m value is negative 0.505. Now so when I come down here and I want to write this regression equation, it said rounded nearest thousands, but I'm going to write it out. M equals negative point, forgot what it was already, 505,613. 505,613. My B value is going to be 67.6319. 67.6319. Now notice how I don't have all the points. If you click on it, sometimes you'll get them, or cancel. Or I can go into Menu, Stats, nope, Menu, Table, no, Menu, Data, no, somewhere. I'll have to remember. Right now I can't remember. So anyway, you can just hover over them normally and get more values. Those are the ones we want. Oh, there's my value. Oh, I was gonna say negative 0.93, but I missed it. So I was close. So so those are the two values. So if I want to write my equation to the nearest thousands place, the thousands place is 3 decimals. Y equals negative 0.506 x equals. Not equals. Plus 67.632. That's a terrible plus. I should get you in the habit of erasing and putting better plus signs. So plus. Now, if you're going to want to write it with d of t, it would actually be t of d. This should be the t of d function, whatever. Y is the temperature. So temperature is equal to negative 0.506 D plus 67.632. That would be a better equation. So determine the correlation coefficient to the nearest thousand. Now the correlation coefficient is R. I'm going to click on R, not R squared, R. So it is negative 0.9259. R is equal to negative 0.925938. So round to the nearest thousands, R equals negative 0.926. Pretty high, pretty high. All right, let's move on. Baby elephants grow very, very quickly. Now, this one's better written. Time in days and weight in kilograms. So we're gonna graph these. So 0, 159. 2, 154. 7, 162. 26 days, we're going to 185. 35 days, we're going to 196. And 68 days, we are going to 229. So I had to graph these. And losing weight that first day is normal for babies. And if you go off the line of best fit, boy, that's really, really close. Like, I'm going to guess right now R equals 0.97. That's my guess. It's really close. Really, really close. Now, my graph might be a little bit off. So let's get these numbers into my calculator. We got to get a new one. So I'll get out of this. No. Yes. And so we got time. In this case, time is our x value. And weight is our y value. So time, 0, 0, 2, 7, 26, 35, and 68. And then, shoot. $159. Oops. Why do I keep hitting that? 159, 154, 162, 185, 196, and 229. All right. So like before, what we got to do is we got to get our cursor up here. What the hell just happened? I somehow scrolled down like 30 cells. We'll get there, we'll get there, we'll get there, we'll get there. There we go. All the way up. And you want to have your blue box right here. We go into menu, statistics, stat calculations. We're going to do linear regression again. In this case, this value is t and my y value is w. And I click OK. And there's my numbers. I wish I knew why. Oh, maybe it's control menu. Data. Anyway. Sometimes if you hover over them. So, let's see. Escape. 1.095. Come on, catch up. Here we go. So my m value, because we got to write the equation, is 1.09548. 09548. My b value is 155.637. 387. All right, so I got to write my equation. Let me do this the right way. So my weight is going to be equal to 1 point nearest tenth, 1.1 days time plus 155.6. My correlation coefficient, I believe, was very high, 0.99588, 0.99588. That was my R value. To the nearest tenth, 1.0 to the nearest tenth. Let's move on. Time and value of your car. Now notice what happens here. When you drive off your lot, you lose a lot of money. And the time must be in years. Okay, so let's see what we got. We'll go back to our calculator. We'll get rid of this garbage. We'll start over again. So in this case, we got time and we got value. I haven't used V in a long time. So time, you're going to go 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. Value 32,750, 32,750, 26,730, 26,730, 24,736, 22,981, 21,421, 21,421, and 2025, 2025. So that's ready to go. Let's graph these suckers. I think this might be the last one we got to do here. Although, I should have asked more questions. So let's graph them. 0, 32, 750. Wow, this graph's terrible. They're going up by 2,000 every time. So there's 0, 32, 750, somewhere around there. 1, 26, 730. 1, 26, 730 is right about there. 2, 24, 700. So that's close to 25. 3, 22, 981. 4, 21, 421. That's 21, right about there. And 5, 20,000, 25. Probably should have put a break in here just to show you that there's a little break. Okay, so, and clearly when I graph that, it's, you know, kind of, to me it looks a little bit more like an exponential decay problem. But let's see what we got here. We're going to do a linear regression, rounding to the nearest dollar amount. So we'll come back over here, and we'll get in our calculator, and we will go Menu, Statistics, Stat Calculations, Linear Regression. We're going to use Time and Value, and click OK. So since I'm only rounding the nearest dollar amount, my slope, let's just write this down. My slope is going to be obviously negative 23. I hate that. Let's go get some more points. This is driving me crazy. Settings. Oh, there you go to settings. Document settings. Float. Okay. Now we get them all. It's up there at settings. There we go. So negative 23.057. 23.057, and my y-intercept would be 3581.476. And while I'm here, let me get this correlation coefficient. R equals negative 0.9508. Negative 0.9508. All right, so my equation round to the nearest dollar is value, or value of t, is equal to my slope, which is, by the way, this was negative 23 t plus 30,581. And then my correlation coefficient round to the nearest tens place. Why am I doing tens place? Just do hundreds. Is equal to negative 0.95. Because negative 0.95 and negative 1. Negative 1 means it's every year it goes down the same amount. Every year it goes down the same amount. That's not the way this is going to be. All right, kids, that's it. That's linear regression with correlation coefficients. I want to add a couple things, though. We're going to go back. We're going to look at these equations because we need to do a little bit more with this. So what I want to say is I'm going to ask a couple of questions. One of my questions is going to be, what would the temperature be if the water depth is equal to 25 meters? Well, what would I do that? Well, I'm giving you the water depth of 25 meters. What do you think you would do with that? Well, I can come over here to my graph and I can kind of take a look at it and I can say, okay, here's 25 meters. This is about where it should be, somewhere between 50 and 60. But I have a linear regression equation. So what I'm going to do is I'm going to plug in that depth. Temperature equals negative 0.506. And we said 25 meters, right? So we're going to plug in 25 plus 67.632. So this should turn out to be somewhere approximately, go to our calculator, oops, well, what happened there? That's Windows 10 for you. All right, well, whatever. I'm going to go to my calculator, and it was, I don't remember the equation, negative 0.506 -0.506 times my temperature, or my depth, which was 25, plus 60. All right, I just can't simply go back. 67,632. 67.632. Oh, it's 66. Dumb. I already had a 6 in. Delete. Enter. 54.98. So my temperature should be somewhere around 54.982 degrees. Round in the nearest temperature. Temperature would be about 55 degrees. So at 25 meters, it should be 55 degrees. Now let me change things up a little bit. Let me change things up just slightly. I'm going to do it up here. Now I want to say, hey, the temperature is 17 degrees. What is my depth? Well, now I'm looking for my depth. So what I want to do is I'm going to plug the temperature in for the equation. So T goes in for temperature. 17 is equal to -0.506 times the depth, which I don't know, plus 67.632. So in this case, I'm going to take 17. I'm going to move that 63. I'm going to subtract 67.632. So I'll come over here and I'll go 17 minus 67.632, negative 0.50, so negative 50.632. So negative 50.632 is equal to negative 0.506 times D. Well, in order to get D by itself, I'm going to divide by negative 0.506. So divided by negative 0.506. And I get 100 point. Does that make sense? That doesn't make sense at all. See, 17, if my temperature is 17 degrees. Oh, yeah. So I'm picking a temperature of 17 degrees, right? That's way up here, 17 degrees. I really shouldn't have picked that. I'm like an idiot. I should have picked a temperature in between these guys right here. Not 17 degrees, but 700 degrees would make sense. 100 feet down, 100 meters down, yeah, it would be about 17 degrees. It would be frozen. Let's take a look. I should have picked a number. I apologize for that. Draw, erase. What I should have done is pick a temperature. See, that's called extrapolation. When you go past the data that's there, you're extrapolating. You're taking instead of interpolating, interpreting means you're going to go within the data point you have. Extrapolate means you're going to test the points outside of your data points. And making extrapolations doesn't always work. You know, at 100 meters down, the water is not frozen. It's cold, but it's not frozen. Let's try a temperature in between here. So let's try a temperature of, let's say, 47. Do I have a 47? I want to pick the one that's not on here. So let's take a temperature of 47 degrees. So temperature of 47 degrees. I should have done this. So 47 is equal to negative 0.506 D plus 67.632. So over on my calculator, I'm going to do the same math. I'm going to take this. Instead of 17, I'm going to do 47. I don't know what having fun with sevens for. Delete. I'm going to do 47. And then I'm going to divide by negative 0.506. And I should be down 40.77 degrees. So if my depth should be about 40.77 or about 41 feet. Well, let's see. If I had a depth of 41 feet, right about here, would that give me a temperature of about 47 degrees? And yeah, sure would be. Sure would be. And I'm going to do it. Let me do the same thing here on an elephant. Let's say there's a big gap between 7 and 26. And there's a big gap here. So let's do a couple things. Let's say we want to ask about time of 20 days. How much would this elephant weigh 20 days? So that's really simple. All you got to do is take the weight and plug in 20. So all I got to do is come over to my calculator, do 1.1 times 20 plus 155.6. 155.6. And I would get an elephant that weighs 177.6 pounds. So the weight would be 177.6 pounds. But I could also say, let's say the elephant weighs, I'm trying to pick a number that's good, 190 pounds. Let's say the weight of the elephant is 190 pounds. Well, now I got to work backwards. I got to say, okay, 190 is equal to 1.1 times the number of days plus 155.6. So to do this, I'll subtract the 155.6. Let's see, if I subtract 155, that would be 35. So this is it's 34.4 is equal to 1.1d. And then if I get out the number of days, I'll just divide by 1.1. 1.1. Now let me see if I make this, let's see if this makes sense. The weight is 190. 190 is right here. So if I go over, my days should be somewhere around 33, 34 days, somewhere around there. So I'm going to take 34.4 and divide by 1.1. Enter. 31 days. So it's about right. It's about right. Remember, it can't be exact accurate. So although we've picked all these things, I want to sell my car after 3.5 years. I'm going to own my car for 3.5 years. And I want to know what it's worth. So all I got to do is plug 3.5 in for time. That's it, kids. I'm done. I'm not going to do any more of those. Hopefully you got it. Hopefully it makes sense. If not, give me a call. Don't call me. Subscribe, though.